Well, good morning, folks. This is the single twist fighter that I etched up in the last couple videos, and I'm hoping you can see them here. Hoping you can see it here in a little better detail, and maybe some of the radical chatoyance that comes with this was twisted in one heat. And I'm not just talking about the twist rows when I speak of chatoyance. I'm talking about the real subtle activity between those rows. To me, is just extraordinary. But anyway, this is the knife, and I'm going to do a bit of a assembly. Yeah, that's fantastic. There's actually rows that go lengthwise in the coarse thread areas of the twist that you really just gotta see, and I don't know if it can be picked up in this video or not. But anyway, I'm going to put this thing together and do some documentation on how I do it. Quite honestly, I still haven't decided what handle material I'm going to use, but it's going to be a takedown. It's going to be a takedown knife, and I might show some of the highlights and key points of putting together a knife like that. I've done numerous demonstrations of these, of how I go about this stuff. It'd be a lot bigger than that, but I'll do some of the key points. And what I've done is this is a mild steel. It's mild steel, and it's going to get hot blued black. And the next little video segment you see, I'll have a piece of handle material chosen for this. Right now, as I'm making this, I don't know what it's going to be, but I'll figure it out. Okay, we are back, and I have chosen. I was going to show. Oh, pardon the jiggy here on the camera. I'm going to pull it off of its mount. But what I wanted to do was just show a little bit of the little bit of my handle material that I keep in bins where they're clean and dry and so forth. And what I have done is I've chosen out of my inventory a block of ringed gidgee from Australia. God, it is so dense and hard, it's hard to believe sometimes. So what I will point out is, as you sort of look at my diagram here, I already have my tang cut off where it needs to be. My handle will get about a 1-inch insert in the butt end as a receiver for the takedown finial. So I have just steel on steel contact, and I'm never messing with the handle material. But I'm going to first dress. I'm going to dress this piece of gidgee and get it right to the thickness, almost to the final thickness. Would be about 15/16 thick, and I'm going to do that first, and then I'm going to cut out the handle profile using my drawing here right out of the handle block before I even start to assemble it. I still see, having been doing this for a while, I still see so much of guys taking a knife, sticking on a chunk of handle material like this, putting it onto a knife, and then stick it on a block of wood like this, and then shaping it into a knife. And I just, pardon me guys, but I just do not understand that. I've probably done that to a half a dozen knives when I started in '96, and I thought, there's got to be a better way. And luckily in '98 I met a fine gentleman by the name of Jerry Radis, and he showed me how to put a knife together, and I will be forever grateful. Anyway, I'm going to go get this in the mill and start cleaning up this shrinkage, and we'll be back. Okay, well, forget everything I just said. The first thing I'm going to do is get this guard fitted to the knife, fitted to the blade. I'm going to lay it where it needs to go on the knife, like so. Then I'm going to mark the back edge of it, and then I'm going to reduce this tang in width quite a bit. Right, I'm going to reduce this, maybe 1/8 of an inch, and then get that guard fitted on here. So hang tight. Okay, there's a lot of different ways of going about this, but one thing I do, and I'll bring this up so you can see, hopefully there's a little better idea. You can see where the guard's dimensions go from the guard shoulder to there, and I've reduced its width just back about 20% of its thickness so that it's reduced in the hole. Now what I'm going to do, remember, I don't know if I said this, but this was before I hardened this knife, and even after in the cleanup, it was surface ground. Surface grinder. This is 261 thousandths thick from here all the way back to here. It's the full thickness is, the full length is all the exact same thickness. So I'm going to go lay this on my surface grinder this way, so that just my tang is on the magnet, and I'm going to reduce the thickness of the tang just 2 or 3 thousandths on each side, so that that guard will just slide right on up, and I don't have to fight it down here. All I got to do is just tweak it to fit when I get up to the guard shoulders. Okay, I hope that makes sense. Okay, we are back, and here's what I've done is I have, hang on, I'm going to turn this just a little bit so we can brighten this up. I have, here's what we have done. I put this on the surface grinder and reduced the thickness of the tang about 2 thousandths on each side. And imagine that that is about the thickness of a piece of newspaper. So that's all I have removed. Then what you might see, I hope you can see this, is that I gently rounded over the corners of the guard, of the place where the guard is going to slide onto it. Just slightly gently rounded those square corners off, because remember that I milled this slot, and I milled it with an 1/8 inch end mill, so the corners are an 1/8 inch radius. Actually, I guess it'd be a 1/16 inch radius, but an 1/8 inch round corner. So if this was milled at the same length as this slot, then we're trying to put a square peg in a round hole. So anyway, I got to round those over. I have not tried to fit this yet, but this is right off. That's the top, I'm going to guess. There, it goes on. And part way onto the guard shoulder. Look at that. Where all we have to do is and you see at this point I don't really know if it's the corners are digging in or if it's the thickness, but I still have my mill set up, and I use these scratches on here as references, and I can go put this right back in the end mill, and I can take 1/1000th off of the guard slot if I want to and make it 1/1000th bigger. So first we're going to just round these over a little bit more and see if it slides on a little bit better. Alright, cool. Okay, let's try this again. Now we're going to slide our guard on. I rounded these I rounded these corners of the guard shoulder area a little bit more to make sure I wasn't hanging up in the corners, and it just won't go on. I can see I'm hanging up a little bit. So what we're going to do here is I'm going to put this guard back in my mill, and I'm going to take another 1/1000th off of each side and then see what happens. Wow, I guess I was just making a really long movie about nothing. I forgot to turn my camera off. But anyway, I just took a 1/1000th of an inch off of each side. And by the way, I only mill halfway through this on each side, and then I flip it over and mill it through the other half on the other side. So these indicator lines here that that I use to line up on that mill vise go around the block. So you flip it end for end. You never flip it. When you ever mill anything, you never flip it like this. You always flip end for end. So you have your same side on your reference jaw, on your stationary jaw. But anyway, this is the first attempt I'm going to make at putting this guard on after removing an additional 1/1000th of an inch. Just 1/1000th of an inch. Look at, I swear, look at that. The only thing that is stopping that from going on is this radius right here at the guard shoulder, which we're going to radius right here on the top and bottom of the guard slot. Almost went on too easy. But we've got a really nice fit at this point, and what I'm going to do is I'm going to take a little hammer and I'm going to peen inward this edge along here. Just going to peen it in on both sides, drive it on with a hammer. That'll compress it a little bit and close up any gap and sort of conform actually to the irregularity of the etched Damascus. So I'm going to file the top and bottom of the slot so it'll hit the guard shoulder radius. I thought I might show just for a second that I have a workstation, a pedestal that I set my vise on so that I can approach the vise from all different angles. And what I have done is set that guard right here in these vise jaws, and I'm going to radius over the top and bottom of the slot. What I have done to radius over those the guard slots is take a small fine tooth single cut file, put it on the surface grinder, and grind off the teeth off of the main side so that I only have teeth on the bottom, so that I'm going in and out of the slot. My teeth aren't hitting the sides of the slot, but only touching the top and bottom of the slot. Okay, here we go. I've been gone from that last video, I swear, 60 seconds to 90 seconds. And now, all of the hand file work I have done on this guard is 1.5 minutes. And we are so close, I'm literally thinking I can tap it on and tighten things up. It is so close. I'm going to move this camera a little bit. I don't want everybody to freak out. There, I just have the tiniest little bit of a gap, and I think I can hit that on with a hammer. And what I have, I don't even know how long I've had this thing now. I don't even know how long I've had it, but it's just a piece of leather. Look, it's actually a piece of leather. It's ancient. It's 15 years old, and I lined it with chamois. And I'm going to just put that on the blade, and that's what I lock into my pipe vise. And if you don't have a pipe vise, get one. Okay, this is my knife, in the pipe vise. And what I'm going to do is, I got to find something. I'll be right back. Okay, what we've got here is 3 6-inch pipe nipples that are, you'll probably be able to see, have been pinched down on the end, and that's what slides right down over the tang. And of course the caps on the top are to hit them with a hammer. I'm going to set my, I got to reach for something here, and what I do, these are pieces of leather. These are just some pieces of leather that I've slotted, and those slide down over the tang and protect the back side of the guard. Like so. And like so. Well, we should be able to see at this point that I have a fitted guard in every sense of the word. I don't know if you can, is it a little better over on this side? A little close up. And I just tapped it into place. Now what I want you to see is this. This is how difficult it is to take it off. Right there. Is a precision fit with zero play and with almost no effort on my part, but that's part of what you get for having a surface grinder and a mill and working them correctly. And I'd rather spend my time building knives than making things fit by hand filing. So we got a good fit here. Okay, well, from what I can see, I've got to take off about 250 thousandths off this ringed gidgee. So I'm going to put it in my mill, and the first thing I'm going to do is mill the two thin sides flat and parallel, and then I'm going to flop it over on the side and take about 100 thousandths or so off of each side. But I'm going to do most of that with a 1/2 inch end mill. And then I'm going to come back with a face mill and clean them up so this block is perfectly flat and true, because I'm going to be standing it up on end later on in the vise to drill the tang hole. So it needs to be standing straight up and down and not wobbly docious all over the place. So I need to get this thing true and sides parallel. Okay, what I've done is taken a 1/2 inch end mill, and I've taken 70 thousandths off of each side, which gets me real close to where I want to be with a 1 inch thickness. So good thing for me, I've got a power feed. Now I'm going to finish that with I can get it out, a face mill, and get these sides nice and flat. Okay, so right now I ended up needing, after let me restate, I used a 1/2 inch end mill because it can take off a huge amount of material quickly without chewing it up. So I used a 1/2 inch end mill to remove about 70 thousandths from each side. And now I'm just going to remove 30 thousandths from each side, and that'll put me right about my finished thickness. And now I will just lower that a couple 2 or 3 thousandths and clean it up going back the other way, and I'll have a handle block. Okay. Alright, well, we got our knife handle material milled down to right about 1 thousandths or 100 yeah, 1,000 thousandths thick, 1 inch. And what I'm going to do is I will cut out this handle shape, lay it on the handle block, and I will cut out my 2-dimensional handle shape right from the get-go before I even start fitting the knife to the tang, the handle material to the tang. It's just, I'm going to say this right now, some folks might think, well gosh, you go to a lot of work to get this done, but I want you to think back to when I fitted that guard. Sure, it took some time to surface grind that handle material, to surface grind the knife, and to mill that slot, but when it came time to put that knife on, put the guard on the knife, it took me 2 minutes of fit time. That's it. 2 minutes fit time, and I had a fitted guard with no slop in it. So I have always said to just so many people, and I've given numerous demonstrations on how I put a knife together, is I would much rather spend my time in front of a mill rather than fighting a file, trying beating a guard on, trying to make it fit. Why do that? Spend the easy time up front, and everything you do, you're going to have to deal with later on down the road. So I try to do what I think the smart work is first, and then it makes the work easier later. My battery's going dead here, and I got to change to a new battery. Okay, now what you see is I cut the profile out. I cut the profile out of the drawing and set it up against the guard, which is in place, just mostly to check alignment of things. And it looks like things are going pretty well. So what I do now is I'll take this handle material with the drawing, with the handle profile on it, and now I'm going to trace this on there and go cut out the handle material in the shape of the drawing, and I will use that then to fit the proceed with the construction of the knife. Okay, 10-4, roger that. I even I take my little machinist square here and mark off the my darn control, there we go. Alright, I use a machinist square to mark off the face, where the face of the handle material is going to be, and I also use the square, and when I lay it on there, I mark both sides of the square, so that this line that you see here, if I cut this line off, I always have a line, a reference, that is running parallel to where I need the face of my handle material to be. So I have 2 lines. This one gets cut off, but if something weird goes on up here, I always have this one to refer to. And by the way, this is my I'm going to go cut this out on the bandsaw right now. Now, I have my handle block in my mill. And what I'm going to do is, I'm going to take that mill, that's my bandsaw cut line, but I'm going to clean that bandsaw cut line up so it's perfectly flat, and then it will be perpendicular to my sides of the block. So it's a perfect 90-degree parallelimity aximoid. There you go. Okay, now I have milled the face of the handle material off, and it's perfectly perpendicular to the sides and flat and true with the back of the guard. Okay, what I'm going to do now is I have an insert that goes into the back, into the butt of the knife, and comes in 1 inch. Comes in 1 inch. And I'm going to make that mark right there, which you'll notice is where I have my tang cut off, just short of that. I already did that. Now, I'm going to determine that I want my threaded tang to exit about right here at this angle that you see me marking. I'm going to go ahead and I'm going to thread this tang a 1032, and it'll be tapered from here to full width here, and then I'm going to heat this up with a torch, and I'm going to bend that tang so the threaded portion of the tang, so it exits the butt of the handle at the angle of the dangle here that I'm looking for. Okay, so I'm going to go thread this tang right now. Okay, now you should be able to see that I have ground this tang down to, it's about 190 thousandths, and I'm going to thread it with a 1032 thread. I've done demos about this at Hammer Ends. I've done works in progress again and again and again on forums. What you do is take this, grind it to a square, the dimension you need, and then knock the 4 corners of the square off and make an octagonal, measuring each one of those, and then just round off those high points, and that's how you get to your round dimension. Now, this goes in the pipe vise, and I'm going to thread it. Another good reason to have a pipe vise: you can rotate this thing any direction you want, and I find this the easiest way to get everything aligned and get things threaded straight. So that's how I thread my tang. I have seen a lot of people go about this a whole bunch of different ways, and what seems so common is to, I don't know, weld on all thread or drill holes and put in other things, but I have always found it so much easier. I mean, what the heck, you've already got the tang there, and this whole process that I've just gone through was a couple minutes. Really, that's all it was, is a couple minutes, and I've got a tool thread that looks like a screw you bought at Fastenal, and I didn't have to weld or solder or drill holes or make things work. I just used what was already there. That's the way I do it. Okay, now I hope you can see these lines on here, but that's the way the tang's going to end up, and I'm going to remove the excess material. So it'll go from full width and taper down to pretty much about where the thread is. So I'm going to go grind that off. Okie dokie. Now we can see let's see, you can see it. This is the tang, threaded, tapered down to its final. What I'm going to end up doing here is putting the guard on. Now you can see that the tang doesn't come out where I want it. So I'm going to go about 2/3 of the way to the threaded portion and bend that so it exits, so it's going to aim right toward the center of the butt and come out where I want it to. It'll be angled, it'll be dipped down. Anyway, heat that up with an acetylene torch and then just bend the tang. Okay, well, I'm hoping you can see the little angle of the dangle I put on this now. I heated it up with a torch, stuck it in the vise, and bent it. And now this portion of the tang exits at the center of the butthole. How about that one? Okay? Now, it's my hopes that you can see this. What I've done is laid the tang on there, and this is what I need to drill out. I'll drill from here. This is where the bend in the tang is. So I'll drill this one angle from the front, and then I'll drill from the butt end at this angle, and they meet in the middle. Then I've got it drilled, slide it on, and I'll stand this up vertically upright, like so, over there in my vertical mill, and drill my holes, and it'll slide right on. And I drill in the center. I'll be marking center, and I leave this flat because it's easier to drill against a flat surface than it is a rounded surface. So once I get the hole drilled through here, then I'll go ahead and shape this off, but I'll leave this to a flat surface until then. Well, I wanted to just mention here real quick that I still have the handle block in the vertical mill drilling it. I haven't exactly decided how I'm going to finish it off, but what I'll do is I'm going to go ahead and edit this video and get it up on YouTube and wherever tonight, and then we'll start another part 2 tomorrow when I decide overnight what exactly it is I'm going to do. So I'll get this edited and hope you enjoy what you've seen so far.